we can discuss about the conic sections. Now, from this topic, at least we get 5 marks in Eamcet. Now, if suppose there is a fixed point, consider S is a fixed point and L equals to 0 is a fixed line. S is a fixed point, L equals to 0, a fixed line. P is a variable point. P is a variable point. Now, the distance between fixed point and variable point is SP, and perpendicular distance from variable point to fixed line is PM. Now, if SP by PM equals to constant, SP by PM equals to constant, then the locus of the point P is called a conic. The locus of the point P is called a conic. Now, conic definition: the ratio of the distances from a variable point to fixed point and a fixed line is constant, then the locus of the point P is called a conic. Now, here the fixed point is called focus, the fixed line is called directrix, and the constant ratio SP by PM is called eccentricity of the conic. Eccentricity of the conic. Now, always eccentricity denoted by E. Eccentricity of the conic is denoted by E. Now, if suppose eccentricity is less than 1, the conic is called an ellipse. If E equals to 1, the conic is called a parabola. If E greater than 1, the conic is called a hyperbola. If E equals to root 2, the conic is called a rectangular hyperbola. If E equals to 0, the conic is called a circle. The conic is called a circle. Now, always the conic equation is second degree general equation in terms of x and y. If suppose ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals 0. Now, it is second degree general equation in terms of x and y. Now, the second degree general equation in terms of x and y represents a conic. If suppose first delta equals 0, delta nothing but ABC plus 2FGH minus AF square minus BG square minus CH square. If delta equals 0, or ABC plus 2FGH minus AF square minus BG square minus CH square equals 0, then the second degree general equation, or S equals 0, consider it. Now, S equals 0 represents a pair of straight lines. Next, if suppose A equals to B, the coefficient of x square equals to coefficient of y square and coefficient of xy h equals 0, then it is a circle. Next, if delta not equals to 0, or ABC plus 2FGH minus AF square minus BG square minus CH square is not equal to 0, then the equation represents a parabola or ellipse or hyperbola. If delta not equal to 0 and h square minus AB less than 0, h square minus AB less than 0, the equation represents an ellipse. If delta not equals to 0, h square minus AB equals to 0, now the second degree general equation, or S equals to 0, represents a parabola. If delta not equals to 0 and h square minus AB greater than 0, the equation represents a hyperbola. If delta not equals to 0, h square minus AB greater than 0 and a plus b equals to 0. Now coefficient of x square plus coefficient of y square equals to 0. Then the conic represents a rectangular hyperbola. Rectangular hyperbola. Now first delta equals to 0. The second degree general equation represents a pair of straight lines. A equals to b, h equals to 0, circle. Next delta not equals to 0, h square minus ab less than 0. The equation s equals to 0 represents an ellipse. If delta not equals to 0, h square minus ab equals to 0, then s equals to 0 represents a parabola. Delta not equals to 0 and h square minus ab greater than 0. The equation s equals to 0 represents hyperbola. Similarly, delta not equals to 0, h square minus ab greater than 0 and a plus b equals to 0, then the equation s equals to 0 represents a rectangular hyperbola. Now we discuss the chapter parabola. Discuss the chapter parabola. If suppose a fixed line L equals to 0, a fixed straight line, S is a fixed point, P is a variable point. Now the distance between variable point P to the fixed point S is SP and PM is perpendicular distance from variable point P to the fixed line. Now if SP and PM, SP equals to PM, then the locus of the point P is called a parabola. The locus of the point P is a parabola. Here the fixed point is focus, and fixed line L equals to 0 is directrix. Always the eccentricity of the parabola is 1. The eccentricity of the parabola 1. Next, the standard equation of the parabola is y square equals to 4ax. The standard equation of the parabola y square equals to 4ax. Now if parabola equation y square equals to 4ax, then vertex of the parabola, it is always denoted by a. Vertex of the parabola is origin, and focus of the parabola is a comma 0. Directrix of the parabola, its equation x plus a equals to 0. Next, x axis is axis of the parabola, y axis tangent at vertex, now vertex is origin. Always the point of intersection of axis and directrix is called foot of the directrix. Next, if suppose a chord of the parabola passing through focus and perpendicular to axis, is called latus rectum. Latus rectum of the parabola. If L and L dash are ends of the latus rectum, Similarly, if suppose any chord just perpendicular to axis, number of chords we get. Now any chord perpendicular to axis of the parabola y square equals to 4ax is called double ordinate of the parabola. Next, if suppose a chord of the parabola passing through focus is called focal chord of the parabola. Any chord just passing through focus is called focal chord. Now a focal chord perpendicular to axis is called latus rectum of the parabola. Next, if suppose parabola equation y square equals to 4ax, the equation of the parabola y square equals to 4ax. Now if y equals to mx plus c, is a tangent to the parabola y square equals to 4ax, then the condition is c equals to a by m. or slope of the tangent is m, slope of the tangent to the parabola y square equals to 4ax is m, then equation of the tangent in the slope form y equals to mx plus a by m, because the value of c equals to a by m. If suppose a parabola y square equals to 4ax. Now a tangent to the parabola. Now slope of the tangent is m, then equation of the tangent y equals to mx plus a by m, and the point of contact is a by m square comma 2a by m, c by m comma 2a by m, or c by m comma 2c. Now if slope of the tangent is m and a is 1/4 of latus rectum, now point of contact in terms of only a and m, a by m square comma 2a by m. In terms of a, m and c by m comma 2a by m. Only in terms of c and m, c by m comma 2c is the point of contact. If suppose the parabola equation y square equals to 4ax, px1 y1 lies outside of the parabola, From external point, two tangents can be drawn to the parabola, Now if suppose slope of one tangent consider m, then equation of the tangent in the slope form y equals to mx plus a by m, If slope of one of the tangent which passes through px1 y1 is m, then the equation of the tangent in the slope form y equals to mx plus a by m, but to tangent passing through x1 y1, then y1 equals to mx1 plus a by m. By taking LCM as m, we get x1 m square minus y1 m plus a equals to 0, x1 m square minus y1 m plus a equals to 0. Now it is quadratic equation in terms of m. Always quadratic equation having two roots. The roots consider m1 and m2. Then m1 is slope of one tangent, m2 is slope of the second tangent, which are passing through px1 y1. Now sum of roots or sum of slopes equals to, or sum of roots of the quadratic equation minus b by a, that equals to y1 by x1. Now sum of slopes of the pair of tangents drawn from px1 y1 to the parabola y square equals to 4ax is y coordinate of given point by x coordinate of given point, y1 by x1. Similarly, product of slopes m1 m2 equals to c by a, or a by x1. Now 1/4 of latus rectum by x coordinate of given point, If suppose the parabola equation y square equals to 4ax, if y equals to mx plus c, is a normal to the parabola, y square equals to 4ax, then the condition c equals to minus 2am minus am cube, and foot of the normal. If suppose parabola equation tangent normal, now this point is called foot of the normal. If suppose slope of the tangent is m, then point of contact is a by m square comma 2a by m. If suppose slope of the tangent is m, then normal always perpendicular to tangent, then slope of the normal equals to minus 1 by m. Now at place of m equals to minus 1 by m, replacing, we get am square comma minus 2am. Now foot of the normal equals to am square comma minus 2am. Next, the parabola equation y square equals to 4ax, then its parametric equations are x equals to 80 square comma y equals to 280. X equals to 80 square comma y equals to 280. Now at the point t means 80 square comma 280. The point t means 80 square comma 280. If suppose the point t1 means 81 square comma 281. Similarly, point t2 means 82 square comma 282. Now the equation of the tangent at the point t is yt equals to x plus 80 square. The equation of the tangent at the point t is yt equals to x plus 80 square. Similarly, equation of the normal y plus xt equals to 280 plus 80 cube. Equation of the normal at the point t is y plus xt equals to 280 plus 80 cube. Now we can discuss the problems. The equation of the parabola having focus minus 1 comma minus 1 and directrix 2x minus 3y plus 6 equals to 0. Now required equation of the parabola whose focus minus 1 comma minus 1 and directrix 2x minus 3y plus 6 equals to 0 plus 6 equals to 0. Consider x1 y1 be any point anywhere on the required parabola, then locus of x1 y1 is the required parabola. From definition of the parabola, sp equals to pm or sp square equals to pm square. Sp equals to pm or sp square equals to pm square. Now sp square equals to x1 minus of minus plus 1 whole square plus y1 plus 1 whole square equals to pm square. Pm nothing but perpendicular distance from px1 y1 to the directrix. Perpendicular distance from px1 y1 to the directrix, that equals to 2x1 minus 3y1 plus 6 by square root of 2 square 4 plus 9 whole square. Now further simplifying, we get 13 into, by cross multiplication, 13 into x1 square plus 1 plus 2x1 plus y1 square plus 1 plus 2y1, that equals to 4x1 square plus 9y1 square plus 36 minus 2ab. Now 12x1 y1 plus 24x1 minus 36y1. Now further simplifying, 13x1 square minus 4x1 square, we get 9x1 square minus 12x1 y1 taking left side plus 12x1 y1, 13y1 square minus 9y1 square plus 4y1 square, 26x1 minus 24x1 plus 2x1, 26y1 minus 36y1 plus minus 36y1 taking left side plus 62y1. Next 1 plus 1 2 into 13 26, 26 minus 36 minus 10. Then locus of x1 y1 is 9x square plus 12xy plus 4y square plus 2x plus 62y minus 10 equals to 0. Now second option is the correct. The equation of the parabola whose vertex is 0 comma 0, vertex is 0 comma 0 and focus is the point of intersection of the lines x plus y equals to 2, 2x minus y equals to 4. Now focus is the point of intersection of given lines and vertex is 0 comma 0. Vertex of the parabola 0 comma 0 and focus is the point of intersection of two given lines. Now by solving two equations we get the focus. Now both equations adding we get 3x equals to 6 for implies x equals to 2. X equals to 2, substitute any one of the equation, we get y equals to 0. Y equals to 0. Now focus of the parabola is 2 comma 0. Vertex 0 comma 0, focus 2 comma 0 given. Required equation of the parabola. Now x axis, y axis, vertex 0 comma 0. Focus lie on the x axis, s 2 comma 0. Now always focus lies inside of the parabola. Now the parabola equation must be in the form of y square equals to 4ax. Y square equals to 4ax. Now for parabola y square equals to 4ax, focus is a comma 0. Focus a comma 0. Now a equals to 2. A equals to 2, substituting in the standard equation of the parabola. Now required equation of the parabola is y square equals to 8x. Because the value of a equals to 2, 4a equals to 8. The required equation of the parabola is y square equals to 8x. Then third option is correct. The vertex of the parabola, y square plus 4x minus 2y plus 3 equals to 0. The vertex of the parabola y square plus 4x minus 2y plus 3 equals to 0. Now actually the procedure is the given equation converted in the form of y minus k whole square equals to 4a into x minus h. The given equation converted in the form of y minus k whole square equals to 4a into x minus h. Then vertex equals to h comma k. Vertex of the parabola is h comma k. But converting the given equation in this form, that is very lengthy problem, very lengthy process. Now in given equation the second degree term is y. The second degree term y. Now the given equation differentiate partially with respect to y, which is second degree term, differentiate partially with respect to that term. We get 2y minus 2 equals to 0. Now y equals to 1. Y equals to 1. Now the value of y substitute in the given equation of the parabola, we get x. Now y equals to 1, substitute 1 plus 4x minus 2y plus 3 equals to 0. But y equals to 1 minus 2 plus 3 equals to 0. Now 4x equals to 1 plus 3, 4 minus 2, 2. Now minus 2. Now x equals to minus 1 by 2. X equals to minus 1 by 2. Now x equals to minus 1 by 2, y equals to 1. Now 1 by minus 1 by 2 comma 1, minus 1 by 2 comma 1 is the vertex of the parabola. Now option is fourth option. The length of the latus rectum of the parabola, y square plus 8x minus 2y plus 17 equals to 0. Y square plus 8x minus 2y plus 17 equals to 0. Required length of the latus rectum. If suppose this equation converted in the form of y minus k whole square equals to 4a into x minus h. First to convert the equation in the form of y minus k whole square equals to 4a into x minus h. Then 4a is length of the latus rectum. Length of the latus rectum equals to 4a. Length of the latus rectum equals to 4a. But converting the given equation in this form, very lengthy process. If suppose the equation ax square plus bx plus cy plus d equals 0. The parabola equation is ax square plus bx plus cy plus d equals 0. Then the length of the latus rectum equals to the coefficient of y by coefficient of x square, because here second degree term is x, then coefficient of y by coefficient of x square, c by a. But length is positive, length always positive quantity, put in modulus. If suppose the equation of the parabola ay square plus bx plus cy plus d equals to 0. Length of the lattice rectum equals to here second degree term y, then coefficient of x by coefficient of y square. Now b by a, length of the lattice rectum equals to b by a, but length always positive, take modulus mod of b by a. Now in given problem, second degree term is y, then coefficient of x by coefficient of y square. Coefficient of y square is 1, coefficient of x is 8, then length of the lattice rectum equals to 8. Now third option. The parabola y plus 1 whole square equals to a into x minus 2. Y plus 1 whole square equals a into x minus 1, x minus 2 passes through the point 1 comma minus 2, 1 comma minus 2. Then the equation of its directrix, given the parabola passing through 1 comma minus 2, 1 comma minus 2. Now substituting the point 1 comma minus 2 in the equation, now at place of y equals to minus 2, x equals to 1, substitute minus 2 plus 1 whole square equals to a into 1 minus 2. Now the value of a equals to minus 1. Therefore the given parabola equation y plus 1 whole square equals to minus 1 into x minus 2. The equation of the parabola y plus 1 whole square equals to minus 1 into x minus 2. Now required equation of its directrix. Equation of its directrix equals to, if suppose the parabola equation y minus k whole square equals to minus 4a into x minus h. The equation of the parabola y minus k whole square equals to minus 4a into x minus h. Equation of its directrix x minus h equals to x minus h minus a equals to 0. X minus h minus a equals to 0. Now here h value minus 2, x minus 2 minus 1 by 4 equals to 0. Now for taking LCM, 4x minus 9 equals to 0. The required equation of the directrix is 4x minus 9 equals to 0. Then fourth option is the correct. The parabola y equals to px square plus px plus q. Y equals to px square plus px plus q is symmetric about the line. Symmetric about the line. If suppose the parabola, any parabola, it is symmetric about axis of the parabola. Axis of the parabola. Because the parabola above the axis and below axis it will be same or symmetric about axis. Now required equation of axis of the parabola. Required equation of the axis. Now equation of the axis. But actually the given equation converted in the form of x minus h whole square equals to 4a into y minus k. Y minus k. Now here x minus h equals to 0 is equation of axis, but the equation converted in the form of x minus h whole square equals to 4a into y minus k, that is very lengthy process. Then just here the second degree term is x, just to differentiate partially with respect to the term. The given equation of the parabola differentiate partially with respect to x. If suppose second degree term y or the equation of the parabola containing y square term differentiate partially with respect to y. Here second degree term x differentiate partially with respect to x, then y derivative 0 equals to 2px plus p equals to 0, p common. Now 2x plus 1 equals to 0. The required equation of axis of the parabola is 2x plus 1 equals to 0, fourth option. If 9 comma 12 is one end of the double ordinate of the parabola y square equals to 16x, then its equation, Now parabola y square equals to 16x. Its axis is x-axis, vertex is origin, y-axis. The point 9, 12. 9, 12 lies on the parabola. 9, 12 lies on the given parabola y square equals to 16x. Because the point 9, 12 substituting in the equation of the parabola, it satisfies. Now required equation of the double ordinate. Double ordinate nothing but it is a chord perpendicular to axis. Perpendicular to axis. Now required equation of the double ordinate. Now double ordinate perpendicular to x-axis or parallel to y-axis. Now equation of the line parallel to y-axis and passing through 9, 12 is x equals to x coordinate of the point, or x minus 9 equals to 0. X minus 9 equals to 0, first option. The focal distance of a point on the parabola y square equals to 8x is 10. Its coordinates are If suppose the parabola, consider parabola equation y square equals to 4ax. Vertex 0, 0. X-axis, y-axis. If suppose Px1, y1 is a point on the parabola, Px1, y1 is a point on the parabola. It is anywhere on the parabola. If S is the focus of the parabola, consider a, 0. Focus a, 0. Now the distance between Px1, y1 and the point S or focus is called focal distance of the point. Now SP is called focal distance. The distance between focus and a point on the parabola is called focal distance of the point. Focal distance. Now directrix. PM perpendicular to directrix. Z is the foot of the directrix. Now from definition of the parabola, SP and PM both are equal. SP equals to same as PM. SP equals to PM. If suppose draw a perpendicular from P to x-axis. Now consider PN perpendicular to x-axis or axis of the parabola. PN perpendicular to axis of the parabola. Now PM equals to same as NZ. PM equals to NZ. Now that equals to, here SP equals to PM or that equals to NZ. Now NZ can be written as AZ plus AN. AZ plus AN. Now AZ plus AN. But always the distance between vertex and foot of the directrix Z, P equals to A units. Now the point Px1, y1, then AN equals to x1. AN equals to x1. Now A plus x1. Now the focal distance of the point Px1, y1 on the parabola y square equals to 4ax is A plus x1, means 1/4 of latus rectum plus x coordinate of the point. X coordinate of the point. Now given the focal distance equals to 10. 10 equals to A plus x1. From given parabola 4a equals to 8, a equals to 2. 2 plus x1. Now x1 equals to 8. x1 equals to 8. Now the point x1, y1 lie on the parabola, then y1 square equals to 8x1, but x1 value 8, substituting y1 equals to plus or minus 8. Now the required points 8 comma plus or minus 8. 8 comma 8 is one point, another point 8 comma minus 8. 8 comma 8, 8 comma minus 8. Now fourth option is correct. 8 comma plus or minus 8. L and L dash are ends of the latus rectum. L and L dash are ends of the latus rectum of the parabola x square equals to 6y. X square equals to 6y. The equation of OL and OL dash where O is origin, where O is the origin. Now equation x square equals to 6y, its axis vertically upwards. The parabola axis vertically upwards. O is the vertex. L dash is latus rectum. L and L dash are ends of the latus rectum. If suppose the equation of the parabola x square equals to 4ay, then ends of the latus rectum are 2a comma a minus 2a comma a are ends of the latus rectum. Vertex is 0 comma 0. Vertex 0 comma 0. Now required combined equation of OL and OL dash. OL and OL dash. Now the equation of OL equals to, that is passing through 0 comma 0 and 2a comma a, 2a comma a. Then its equation is now passing through 0 comma 0, 2a comma a is ax equals to 2ay. Now a cancel, x minus 2y equals to 0. It is equation of OL. Similarly, equation of OL dash. Equation of OL dash. It is passing through 0 comma 0 and minus 2a comma a. Now we get x plus 2y equals to 0. But required combined equation of OL and OL dash. Combined equation of OL and OL dash. By multiplying these two equations together, we get now combined equation x minus 2y into x plus 2y equals to 0. Now x square minus 4y square equals to 0 is the required equation. Now option is second option. The angle subtended by the double ordinate of length 8a of the parabola y square equals to 8ax. Y square equals to 8ax at its vertex. Now x axis, y axis. The parabola equation given y square equals to 8ax. Y square equals to 8ax and length of the double ordinate given 8a. Length of the double ordinate equals to 8a. Total length. If suppose consider PQ is the double ordinate and axis of the parabola bisect the double ordinate. Axis of the parabola bisect the double ordinate. Now this point consider R. Now R is midpoint of PQ, but PQ equals to 8a, then PR equals to 4a. PR equals to 4a, RQ is also 4a. Total length equals to 8a. Total length of the double ordinate equals to 8a. Now x coordinate of the point P 4a. Now y coordinate consider y1. Y coordinate equals to consider y1. Now the point 4a comma y1 substituting in the equation, now y1 square equals to 32a square. Sorry, here length of the double ordinate 4a. Total length equals 80, it is 4a. Y coordinate equals to y coordinate equals to 4a. X coordinate consider x1. X coordinate consider x1. The coordinates of the point P x1 comma 4a. x1 comma 4a. Now the point x1 comma 4a substituting in the equation of the parabola y square equals to 8ax, then 4a whole square equals to 8a x1, 8a x1. Now 4a whole square equals to 16a square equals to 8a x1. Now x1 equals to 2a, x1 equals to 2a. Now x coordinate of the point or OR equals to 2a. Sorry, parabola, just a minute. Parabola equation, sorry, 4a x given, y square equals to 4ax, y square equals to 4ax. Now substituting 4a x1 equals to 16a square, x1 equals to 4a, x1 equals to 4a. Now OR equals to also 4a. Here x1 equals to 4a, then OR equals to 4a. In triangle OPR, OR equals to PR. Two sides of the triangle are equal and one angle is 90 degrees. Remaining two angles each must be 45 because right angled isosceles. Now similarly in triangle ORQ, angle O is 45. Now the double ordinate PQ subtend an angle 90 degrees, total angle 45 plus 45, 90 degrees at the vertex. Then option is third option.